To explain the seeming contradictions between particle and wave behavior and the impossibility of measuring certain quantities simultaneously with perfect accuracy, Erwin Schrödinger developed the wave function and his famous wave equation in 1926. Significant work was also done by Paul Dirac, and the two share the Nobel Prize for Physics in 1933. In classical physics, if all the forces on an object are known, all other quantities such as position, momentum, acceleration, etc. can be found. And in classical physics, we've always assumed we can measure things to an incredible precision and then predict exactly what is going to happen. Physics is very different on the scale of atoms. Light is described as a wave and a particle, the electron is described as a wave and a particle, and the uncertainty principle says that there's a limit to how precisely position, momentum, energy, or time can be measured. Schrödinger conceived the idea of the wave function and assigned these wave functions to quantum objects, such as the electron. Once wave functions are known, it is possible to calculate the possible and expected values of physical quantities in the quantum world. Where classical physics provides one value for position, momentum, and energy, and other things at any given moment of time, quantum physics and Schrödinger's wave equation will give many values of those quantities together with their respective probabilities. The key word here is probability. This makes the quantum world very different from the more predictable classical world. The Schrödinger wave function is quite useful, as we already discussed. One of the applications is to find the probability of where a particle is. For this, we, quote, square the wave function. This was first suggested by Max Born. This probability distribution is what we would look at if we wanted to predict the interference pattern that would be seen on a double slit experiment, for example. Now, just for fun, here's Schrödinger's equation. I won't even read it to you, but you can see its form. It turns out that solving this equation for the wave function will enable you to understand everything there is to know about a particle. You can learn more about this in advanced university level physics.